All right, we are in the home stretch, but by no means done with all the good stuff. So now, so that was a little brief window into what we're doing, really training the young students to really think differently, to really understand how to embrace the tools that we're going to deliver to them when they get into the professional world. Now we'd like to pivot to our incubator, also looking forward, but not so much the future of the individuals, but the future of innovation. How we're using our 3D Experience labs to incubate new innovators and bring them up that curve as quickly as possible. And you've seen some examples of that, how we can do this. Now we're going to hear from the leaders of our 3D Experience Lab, the formal program that we onboard, we mentor, and then we enable and put them out to be successful. So with that, I would like to invite the representatives, Jillian Friot,
Thank you.
to the stage.
Thank you very much.
Who are you?
Thank you.
The stage is yours.
Thank you very much. At the Dassault Systèmes 3D Experience Lab, we believe that if we accelerate disruptive innovation, we can positively impact society. All of us on the 3D Experience Lab team are intrinsically motivated by the opportunity to support startup innovation that positively impacts society and has the chance of helping with any reduction on the negative impacts to society. And we believe that if we show the dream is possible through the stories of the startups and the projects at the lab, that we can inspire others to create change and to create solutions to the toughest challenges that we all face today. I'm Jillian Friot. I'm the Senior Manager at the 3D Experience Lab in North America. And I will be joined shortly on stage by my colleague, Farrell, who's the Technical Specialist at the 3D Experience Lab, as well as one of our beloved startups of the lab, DynoCardia, who will share their story and share the challenges that they're working on. But before we invite them up on stage and before we dive into that, I'd like to go on a quick journey together. When we think back on the journey of Dassault Systèmes, and actually of the lab itself, the lab was founded around 7 years ago by Frédéric Faché, the head of innovations for Dassault Systèmes. And looks like sorry, let me get our slides right here. So yeah, the lab was founded around 7 years ago by Frédéric Faché, and he was inspired by the story that Bernard shared earlier today with us, that we ourselves, as Dassault Systèmes, were a startup only 40 years ago. And we had our own humble beginnings in our startup journey, which really began with just a bet. And we've come a long way since that one bet in our mission to harmonize product, nature, and life. And that first bet was really about that transition from changing the world of engineering from 2D to 3D designs. We had the opportunity to disrupt the market with that technology. And when Frédéric shares the story and likes to think back on that, we also look at that bet really led to additional bets, and it was a good bet. We bet also that we could extend beyond just traditional 3D designs, but actually go into complex assemblies as well, and go from simple to complex digital mock-ups, and then from mock-ups to virtual twins of almost everything around us, and first being designed in our software before being brought to life or modified in our physical world, saving us time and resources and saving the planet from unnecessary waste. The story of our evolution is not only about digitizing our products and simple parts, but also about the processes. It's also about Dassault Systèmes customers creating virtual twins of their entire processes, including the robots that build the parts, to the environment surrounding it, and the industrialization processes, all happening in the 3D Experience platform. 80% of the impact occurs in that engineering and design phase. So from design to engineering, simulation, production, we can operate in a virtual world that increases the effectiveness that we as a society will face in our physical world. Digitizing design with intentionality such as this really drives that need for collaboration in that virtual twin. And the speed to innovation increases with that ability to come together as a community and solve problems together in a virtual twin, including those as complex as the human body, as we're talking about today. And we at Dassault Systems are very grateful for the opportunity, for this foundational knowledge that it's allowed us the opportunity to invest in the science of virtual human twins and to invest in the future of virtual human twins. When it comes to the 3D Experience Lab and virtual human twins, we like to reflect on this journey for 2 reasons. The first is to remind ourselves that innovation is typically done in industry. We've seen it done across industries for a long time from a top-down approach, but that it doesn't only need to occur as a top-down approach. And actually, it's necessary for us to innovate, to take these innovative bets as we did in our own startup journey, both as large corporations, but also as new stakeholders, as startups and makers. And for those startups, they have a unique advantage of taking a higher number of risks and a higher number of bets, but with more time, more flexibility of being nimble. And they are nimble enough to quickly act on those bets. And so coming together with this bottoms-up and top-down approach, this hybrid approach to innovation is really what we need to drive that forward and make these bigger changes for tomorrow. So the lab is here to support startups who can take big bets and giant leaps towards a better tomorrow. And we bet as the lab that if we support these startups, we can see disruptive innovations sooner in our world. Which brings us to the second reason to reflect on our journey. And let's see if I, oh, sorry, go back. And when it comes to that second reason to reflect on it, it's our strength in collective intelligence and community collaboration on the 3D Experience platform. Our strength in our own unique advantage as Dassault Systems is our ability to collaborate and initiate open innovation and community collaboration with others who have that same vision, who share that vision for harmonizing product nature and life. And with Dassault Systems technology, we all have the opportunity to call upon and support a much larger and more diverse group of people to solve problems collectively, tapping into that collective power and collective intelligence of collaboration on the 3D Experience platform. And this is why we believe in supporting disruptive and impactful innovations by startups and makers in the Dassault Systems 3D Experience Lab, and why we're motivated to find the most disruptive startups from around the globe to be a part of the lab, providing them with Dassault Systems tools and resources to accelerate their technology for a better tomorrow. We aim to inspire people to find the solutions to major challenges we all face in front of us in healthcare and beyond. And the lab exists in both a physical space and a virtual space. Startups can be located anywhere in the world and be supported by the lab, and they stay connected to us through the 3D Experience platform, while also having access to our physical lab spaces located here in Boston, in Paris, in Munich, and Pune, and we continue to expand those physical office spaces as well. And then they also stay connected to us and supported through a network of mentors from around the globe who are both internal and external to Dassault Systems. And although we wish we could support every high impact and super disruptive startup that's out there, we're grateful that we currently are supporting around 40 startups as part of the lab. And those startups have come from over 850 applications to the 3D Experience Lab program. And startups apply online and enter into our own idea funnel, which is used on our own 3D Experience platform. Our team extensively reviews each application and moves them along the idea funnel to look for that mutual benefit and the fit between what the startup needs access to and what we're able to provide as the lab. And this all culminates in a pitch competition to the Dassault Systems senior leadership team, as well as any other Dassault Systems employees are welcome to join and vote for the technologies that they wish to see brought to their world. And those who are accepted are entered into our official program of the lab. And this is a zero equity program, meaning we take no equity stake in their business. and offer them this unique access to mentorship, technology, and to our marketing engine of Dassault Systems. And to find these extremely impactful startups and all over every corner of the world, we partner with the leading clean tech incubators and accelerator programs, and we work closely with them to understand those that are a good fit, and really look for those that share our same value system and beliefs of really supporting a sustainable future. Typically, we meet startups when they're in an idea stage, and we help to support them with their 3D modeling and their prototyping. And then we work with them through at no cost for 2 years, and then we work with them through their industrialization and commercialization of their product with deep discounts and other access, and really help to accelerate that technology for them. Our team works closely with them through this whole journey, and especially on the technical side. So I'd like to invite up my colleague, Sean Farrell, who works very closely with them on the technical aspects of their startup. So Sean, would you please tell us more about all that the lab has to offer?
Sure.
Pass this on.
Thank you, Jillian. Thank you, everyone. Yeah. So first and foremost, if you're a startup out there physically in the audience or virtually, and you're working on a tough technical challenge for better cities, improved nature, and enhanced lives, feel free to connect with us afterwards, and we can talk about getting you to apply. But so we offer, like, in the 3D Experience Lab, we offer 4 main things. Firstly, access to the entire suite of DS cloud solutions. So, like I said, all of the solutions we offer are on the cloud. None of them are like standalone solutions. So anything from SolidWorks and CATIA to BioVia and Innovia, we give these startups access. So for example, you might recall Atacama Biomaterials. I spoke yesterday at Science in the Age of Experience. And they were recently brought into the lab in this past cohort, and they're using SolidWorks, CATIA, Simulia, and even BioVia solutions. So, for example, we help these startups. The important thing is a lot of these licenses can be expensive because it is incredible software. And for Atacama specifically, their licenses, after all said and done, added up to well over $1 million. So for a technical startup working on technical solutions, that's very important for them to gain access to. And then next, we provide access to technical mentorship. So any DS employee, around 20,000 or so across the globe, can dedicate 10% of their time annually to provide mentorship to these startups. So we've had incredible mentors from all of the brands give amazing mentorship to these startups to help them learn the software and to help them propel forward. Also, we have an incredible marketing team internal to the 3D Experience Lab that provides marketing assets. We bring them to CES, actually DynoCardia, who you'll hear from momentarily. We brought them to CES this past January. We go to TechCrunch, VivaTech, which is kind of like the CES of Europe, an amazing event that I haven't gone to yet, but I hope to go to soon. Paris Air Show, and then access to fabrication labs. So we have fabrication labs in Boston, Tbilisi, Munich, and Pune. And so we have state-of-the-art 3D printers, SLA printers, laser cutters, 3D scanners, a bunch of technology to help them prototype. And in terms of the Boston lab, we're continuously trying to improve and get more equipment and organize the space so that startups can come in and do their work with us. Pre-COVID, that was the case, and during COVID, obviously we couldn't do that, so it's nice to get back into that. And also we partner a lot with, as Jillian mentioned, accelerators all across the globe, and so we really want to start to gain access to wet lab space through J-Labs, IndieBio, which are med tech and life science accelerators. Also, we try to make sure that any startup we bring on aligns with at least one of the United Nations Sustainable Development Goals. And yeah, so one thing I'd like to mention, by the way, is at the most recent Virtual Twin Symposium in Brooklyn, I think it was back in November or December of last year, we brought the Vortex virtual reality simulation. And I don't have it on the slide here, but the next Virtual Twin Symposium, we'll be sure to bring it. This one we weren't able to, but essentially this is just a virtual simulation of the CyberKnife radiotherapy procedure. And it's a very intimidating procedure because you have this huge robot that's navigating around you, and it's similar to an MRI, except you've got a massive robot moving very close to your body. So it's important for patients to gain a better understanding of what they're about to get into before they do it. So this simulation, basically the 3D Experience Lab also works on projects, not just startups. So this Vortex simulation is a project that was done in conjunction with the Hartman Institute of Radiotherapy in France. So be sure to attend next symposium if you want to see that. And I'll just jump through this, but I think this is a great segue into DynoCardia. Mohan, please. Good luck. Yeah, green ones go.
Okay. So a quick introduction to myself and the company. So I'm Mohan Thanikachalam. I'm the CEO of DynoCardia. And I'm also a cardiac surgeon with a long-standing interest in public health. Since 2015, we're funded by NIH, and I've led a joint Tufts Medical School and MIT team, and what we believe will come up with a fundamentally a different approach for measuring blood pressure and cardiac hemodynamics. As of June of 2020, we established DynoCardia to commercialize the technology, and the partnership with Dassault from day one, June of 2020, has been truly transformative, and thank you. Thank you for all the support. So all of you know how we measure blood pressure. We've been doing this for the last 100 years, particularly over the last 50, 60 years. The current standard of care is this automatic cuff. There are two issues with it. One is the inaccuracies. On routine measurements, they can be off by 10 millimeters of mercury every other time. And even if you manage to measure it accurately, we do get only single-time measurement. And blood pressure changes a lot. From me standing here and here, my blood pressure has changed. So why it is important? I'll give you some examples. In patient, everybody gets a cuff and leads to a monitoring gap. We know it's clearly linked to episodes of heart attacks and kidney damage, and extra cost to the healthcare system. If you look at it in the outpatient setting, in this country alone, there are 100 million people with high blood pressure. We're wrongly diagnosing 30% of the people. Blood pressure control is a major issue. Another example is nighttime blood pressure. It's a major cause of mortality, but in a routine basis, we are not able to measure it. So having looked at blood pressure the last 100 years, the only way we can accurately measure blood pressure now is actually putting an invasive arterial line. If you go to, across here to Tufts Medical Center, close to 40% of the ICU patients we put an arterial line in. That's the only way we can get accurate measurements. So to understand how our technology works, I'm going to go back a second here. Yeah, so when you feel your pulse at your wrist, what you feel is actually the force transmitted from the pressure wave inside the blood vessel. First, we built a unique optomechanical sensor, which has much higher spatial resolution than your fingertip. So essentially, when you put the sensor on, it takes continuous video, high-resolution video images of your pulsation, from which we reconstruct the pressure wave, and we are shown there's a linear correlation with what we see in our sensor and intravascular pressure. Then we have a very proprietary method by which, for every beat, we can tell what's the maximum pressure inside your vessel, that's your systolic blood pressure, and your baseline pressure, that's your diastolic. And in the technology also, we can derive cardiac output and other advanced hemodynamic parameters. We could also look at your respiratory rate and respiratory parameters. So integration of a pulse ox becomes a comprehensive monitoring solution. So we've done extensive large and small animal studies. Compared to invasive arterial line, we've shown very good correlation. In the outpatient setting, is a well-trained healthcare professional using cuff and stethoscope is still the gold standard. We compare them, we have shown that our technology can independently measure blood pressure. This doesn't need any external calibration. So the output from the device is in millimeters of mercury. So we see a wide application across healthcare markets. So our initial focus, this is particularly because to get the buy-in from the medical community. And how do you say our technology is accurate so that we can compare against invasive arterial lines? So our initial focus is in critical care. And we are in touch with some of the top physicians here in this country, Europe, Japan, and also some of the large hospital systems. And this is what we learned. How our technology can benefit is by providing accurate 20-second blood pressure output. As accurate as the invasive arterial lines, can immediately benefit 50% of the major surgeries currently in hospitals, and close to 75% ICU patients. And the feedback is potentially we can replace close to 70% of the arterial lines. The other important thing is able to monitor patients across the care continuum. What happens is we're all focused on the patient in the ICU for 24 hours. Once they go to the general medical wards, everything changes. Everybody looks at them every 6 or 8 hours. And if you really look at it, that's where complications happen. So if you look at post-op mortality, it's the third leading cause in this country. And if you look at most of it, it's related to cardiovascular and outside the ICU and at-home settings. So the technology will go with the patient, the critically ill patients, in the general medical wards into patients' home. And the third is we know even very small, even a 1-minute episode of low blood pressure we know can be damaging. So able to have some kind of a decision support, particularly in the general medical wards and home, if there's a low blood pressure, it's because of preload or something to do with the heart, able to act and immediately will potentially also save lives. Our technology can do that. And lastly, of course, this is the holy grail, if you can actually predict before the acute decompensation happens. And that is the true benefit of continuous measurements. So for us, what we are focused on is to show this technology works across patient populations. Wide range of blood pressure across patients with arrhythmias. So we have, in the middle of a multi-center trial, and looking at trauma patients and post-op patients and pregnant women with high blood pressure. So a wide range of patients where we're currently collecting data. And one of the things we have focused over the last 1 year has been, when you say continuous, how do you do it when the patient is actually moving? If you say, I'm going to do 24-hour measurements, you can't keep them tied down. So how do you actually do that? So what I mentioned is what we're doing is we're taking continuous video images. So we're bringing the latest in image processing techniques, where when somebody is moving the wrist or hand, able to quantify in the video images in real time, correct for it. So that's one big advantage of our technology. So here's an example of an ICU patient. So our device has motion sensors. It tells, hey, the patient's actually moving. And here's the invasive arterial line. You see a disruption in the signal. And if you look at the blue is our signal, where we are able to, except for 1 or 2 beats, we're able to continually recover those signals. So this is a summary of some of the more recent data. These are challenging set of patients where the patient actually has an invasive arterial line in one hand, which is tied down, and then they're essentially using our hand to take a cup of water. And in spite of that, every 20 seconds, we are able to get, as FDA-defined, accurate blood pressure measurements. This is over 2 hours. So, and the other thing also, we have an active collaboration with the Mayo Clinic, and where a lot of the efforts in this predictive monitoring, also looking at historical data and our data itself. Here's an example of a patient in the OR where we're able to predict patient decompensation at least 10 minutes before. So here is the collaboration. One of the examples is the wide range of collaboration with Dassault Systèmes. So one of the collaboration is in how do we supplement our clinical studies? BMI, high BMI, or arterial stiffness, we know affects blood pressure measurement. We think we have a unique solution which can be better than the current standard of care, but how do we prove it? And some of the people or the physicians in this audience will know it's very tough to measure arterial stiffness in routine practice. And how do you say, here's the soft tissue, level, right? So So for us, is supplementing that information. So here's one of the model here using an MRI model where using ultrasound data, our own data, and also historically where soft tissue arterial parameters have been inputted, and then you have a finite element model. So I'm going to go back and the animation. So for us so we have a model now that basically simulates the arterial pulsation and the force distribution onto the skin, and other studies that we have been involved is, for example, we have collected data on 8,000 subjects, active living subjects, age group of 18 to 78, the arterial stiffness information. Now we can actually input those measures into this model and see how it actually affects our measurement. Just one example of how we could work, how we can use this model. Other one is varying the soft tissue level and see how it affects our measurements. So these are some of the ways we are trying to use some of these models we have created. So our goal is, we expect to finish this multi-center trial by the end of this year and actually have a product in hospital sometime next year. And here's our team. It includes both the scientific co-founders and as well as people experienced with both marketing and as well as product development. Thank you very much.